Alright, hi guys, this is Mr. Zarzak, and we're back down in my basement with a little underground physics. The demonstrations that I'm going to show you today are designed to help you understand practice file 8-1 a little bit better. Okay, so the first thing I'm going to show you is a periscope, which I have set up here right in front of me. So you understand what you're seeing is down here I have a little green laser beam and it's shooting inside the periscope. So the periscope has a mirror that's set at 45 degrees. I'll show you this a little bit closer in a second. But the idea is that the incident light comes in at 45-degree angle, so that when it reflects, it also reflects at a 45-degree angle because my mirror is at this angle, at this slant here, set at 45 degrees. The little light beam goes in, it bounces up, travels up to the top of the periscope where there's actually a second mirror. That second mirror is positioned like this at a 45-degree angle, so the light comes up, hits at an incident angle of 45 degrees, and so then reflects out at an angle of 45 degrees. And so you can actually see here there's a green dot that I have that I'm using for my green laser pointer that's bouncing up and hitting the target. If I take and I jiggle this a little bit, hopefully you can see the target moving around. And if I take and I turn the lights off, you should be able to see the dot a little bit better. Over here I've got a flashlight, so if I shine this through and take the laser out, you can actually see the light coming through the periscope. See, so I'm shining it down here, and it's traveling up the length of the tube up to the top of the periscope. Okay, so now I have all the lights on, so I thought I'd take you in for a closer look at the periscope so you can see how it works. Okay, so looking down here, you can see the mirror. You can actually see me filming here. Now, this isn't going to let me see the target on the wall because now I'm facing down at about a 45-degree angle, so all I'm getting is the mirror, the reflection of my stuff self-staring back. I'll show you what it looks like to look through the periscope in a second. All right, but just so you can see, over here if I peek into the periscope, there's that secondary mirror mounted at that 45-degree angle. And then I'm just going to get down eye level with the periscope here so we can look into it, and hopefully, there is the target. Okay, up on the dry erase board, which you can see right there. Okay, so pretty cool. Okay, so then a little bit later on in the practice file, you run into a mirror that looks like this. It's a curved mirror. The curvature actually goes in on itself. So if I come around to the back side, so that you can see the shape here. So the shape of it, it winds up bending in on itself. So we call that concave. And in fact, a little memory trick for this is that the direction that it curves is, since it curves into the middle, it's almost like it's a little hole, almost like the entrance to a cave that you're going into. Okay, so in the practice file, what you see is that there's a candle that's placed in front of this curved mirror, and it's at a very specific point that we call the focus point, so that when the light reflects off of this, it all bounces off the mirror parallel to itself. I'll show you what that looks like in just a couple minutes here, but before I do, I wanted to show you the practical application of this, and one of the practical applications of this is a flashlight. So if you've ever looked to the inside of a flashlight, you see that there's a reflective surface that bends inward, so there's a concave mirror, and then the light bulb that gets turned on. It's actually not that powerful of a light bulb, but because it's placed right at the focus point of this concave mirror, all the light comes out in one single direction. It all reflects parallel, or in what we call a beam. Okay, so that's the idea. Unfortunately, this one's out of batteries, but I do have another one, but this one's nice and big and easy to see what's going on the inside. Okay, so hang on one second. So I've got a little smaller concave mirror that I've got mounted on this piece of plastic. See, so like here's the big one over here. Okay, I'm going to use this one, and I'm actually going to take a light bulb and I'm going to put it right at that focus point and shine it on the wall in the dark so you can see what's going on. So here, let me go get the lights off. Just hang on a second. Okay, so here's that little mirror I was showing you before, this little concave mirror, and I've got a flashlight I'm actually going to take it. I'm going to shine it into the mirror, and the reflection is going to go out on the wall over there. Okay, so I'll just try to hold this in front the camera as best I can without blocking anything. Okay, and if you can see out there, there's the light that's going on the wall, and you notice that if I change the distance of the light from the mirror, okay, that ball gets more or less focused. So if I find that most focus point, okay, this is when the flashlight light bulb is literally at this thing that we call the focus point, and what I get on the wall is this spot of light. And so the name that we give to this is what we call a spotlight. If I just move and I change the angle, see that light on the wall, that spot just remains the same size because all the light that's bouncing off the mirror is all bouncing off parallel to itself, so it never spreads out or comes together. Let me show you the exact same thing, just the lights off in the room, just for effect. Okay, so now it's nice and dark in here. So I got my flashlight here, I'm holding my mirror. Okay, and so if I've got the flashlight too far away, the light spreads out. If I get it too close, it starts to spread out again. But if I get it right at that focus point, okay, well then I get this spot of light, okay, that doesn't change size because all that light is reflecting off the mirror parallel to itself. I've made a spotlight. Okay, a common name for that would be, say, like the headlights on your car or a flashlight. It really depends on the application. Okay, but that's the idea. All right, this is Mr. Zarzak saying thanks for watching, and we'll see you next time.